I'm working on the crystal sync software next, but now I'm working on the shutter parking and inching. So I made this inching trimmer to work. So and the direction is correct too. So upwards clockwise, down counterclockwise, lowers the inching speed, and I have the input-output module here. You saw it in the previous video, so this enables controls of this connector. I have the start-stop control here, that's ground, and the brown wire start-stop. The pink one is inching, and I have the shutter sensor here. So let's see, this is running wild at the moment, so because I'm testing it out. So it's now running wild. Then at some uncertain speed, because it's not regulated, it doesn't have the tachometer. It's the sensor disk and it connects to white connector. So now I'm switching it off if I can. And now it goes to the shutter parking mode. So now it works at the inching speed. Let's see. You can see I can control, this is the inching speed. So now it's in shutter parking mode. So if I cut the light on the shutter parking sensor, now stops. Then if it didn't stop correctly, then it tries again and tries again. Now it doesn't try anymore. So it counts the tries. It has 3 tries at the moment. I might lower it to 2 tries because it can be annoying if it can't find the mirror positions and tries and tries and tries. So I might lower it to 2, but it's 3 now. So now I have the inching here. And inching works if you push the inching button and then it stops. So this looks different when it's actually mounted on the working camera, because then there is lots of friction, so it stops almost instantly when cutting the inching. And the inching speed needs to be adjusted with the actual camera with film inside, because scratch film, of course, don't waste actual raw stock on adjustment, but it needs to have some kind of film inside when adjusting this, because the friction is way different and it affects this speed. And if you set it too slow, then it cannot shutter park and it cannot inch properly. So if it's too high, then the inching is annoying, and then shutter parking may not work all the time. So it might work once and then fails the other time, and so on. So if it tries to spin it too fast for 1 revolution, and it tries to stop and it doesn't stop because it spins too fast. So it needs to be adjusted with film. But if you have the continuous inching adjusted with film, then the shutter parking should work. It's made that way. But now I have this, I have the connections working, and then the shutter parking sensor, and its working logic is okay. The inching speed works. Now what I'm going to do is then work on the crystal sync, and then we have this blooper marker output. So when the camera starts, it waits a little for it to reach speed, and then gives a small mark. So you could connect a summer or something to the blooper marker if you want. Often it needs some kind of amplifier to connect it, but anyway. Or you could even have a flashlight which gives some arc, so it actually shows in the film. Or your camera's gate, or I think CP16R has some slot near the mirror where one could add the blue marker light, so one could add it there, so it focuses the film when it gives the mark, and it gives the audible mark and then focuses the film at the same time, so for short periods so one can find that mark easily. But I'm working on that next, and frame pulse output works because it's linked to the shutter parking sensor that works already. So the crystal sync and the blue marker are next. But we have this so now it's in shutter parking mode. If it found the mark, then it stops. Then it tries again. No, it doesn't try anymore. And the inching speed works too. So I have those working now. I have coded the rest of the features, but I haven't tested them yet, so I need to test them in stages because it's too difficult to find issues if trying to test them all at once, because you can't figure out which glitch causes the issue. So, and you can see I have the programming device connected to it for this test, so I can easily update the program, and then on this motor control microcontroller I have the crystal reference microcontroller separate, like on most of my systems. So there's separate microcontroller running separate program which generates the reference for this crystal sync system, and this microcontroller runs the reference generation and the display, and this runs the actual crystal sync. So that's how I'm doing things on most of my systems, because it's because it's easier to find issues that way when not trying to include all the features in the same processor, because there's critical timing stuff which can be messed up if you are running for example display with the same microcontroller that you are using to run the motor sync control. So I'm dividing them into separate microcontrollers, which enables me to work faster usually. So I haven't uploaded the display software yet here, but I'm working on this now, and then when it works, then uploading that. It's ready but not tested with this board recently. I tested it with the previous version, this one. So working on the crystal sync next. So I'm installing the encoder board here, and then making the cable and starting the run sync tests.